Hi, we are looking at Chapter 5, Section 1, Midsegments of Triangles. So, first thing we have at the top is a definition of a midsegment. It's the segment that connects the midpoints of two sides of a triangle. And so, if you take a look at the picture below, we have the triangle midsegment theorem, and this is going to come in handy. The midsegment of the triangle is parallel to the third side of the triangle and half the length of the third side of the triangle. So in this picture, if we know that M is the midpoint of segment AC, and we also know that Y is the midpoint of segment AD. If we know that information, we can go ahead and mark the picture. And therefore, segment MY must be a midsegment of triangle ACD. Okay, with that being said, what the theorem now tells us is segment MY must be parallel to segment CD, the third side of the triangle, and pretty obviously the only side of the triangle that looks parallel to segment MY. The theorem also says that segment MY will be half the length of segment CD, or if you'd like, you can look at that statement again. Are you a glass half full or glass half empty kind of person? And you can say that double the length of segment MY equals the length of segment CD. Okay, so again, this segment is parallel to the bottom. That's what the theorem says. It also tells you that this segment, again, is half of this one. Okay, we're going to move on to the examples on page 2. Okay, we're here on page 2, and we're looking at the first example. It says that point C and point E are midpoints. And if we take a look at the picture, that means point C is a midpoint, point E is a midpoint. And since they're both midpoints of two sides of this triangle, we would say that segment CE is a midsegment. So once we know that about segment CE, then the theorem kicks in, and we know that if segment BD is 32, we are guaranteed that segment CE will have a length of, you got it, 16. Okay, on the second problem, again, we're told C and E are midpoints. Therefore, segment CE is a midline again, and we can see it's parallel to the base. We're being told that BD is 7Z minus 1. Don't forget to write on your picture. We're being told the length of segment CE is 3Z plus 2, and we're being asked to find Z. So what I recommend is the first thing you should do is write down the relationship without the variables. Just use the names of the segments. So I know, because of midsegment theorem, that segment CE is half of segment BD. And that's important because now that I've written that statement, I can go ahead and fill in the variable statements, which is that 3Z plus 2 equals 1/2 of 7Z minus 1. Oops, 7Z minus 1. At that point, you go ahead and do the algebra. And to start that, I definitely recommend you multiply by 2 on both sides so that you can get rid of that fraction. That creates 6Z plus 4 equals 7Z minus 1. The 2 would cancel with the fraction, the 7Z minus 1 would stay as it is, and then you can continue to solve and you end up with z is equal to 5. Okay, bottom of the page, you have this lovely picture, and it says points M, N, and P are midpoints of the sides. So we're going to go ahead and multiply. Those guys are all midpoints of the sides. What that means then is, in this picture, segment MN, segment MP, segment PN, those guys are all mid-segments. Okay, that being said, we know that they're all parallel to a third side of the triangle, and they're all half the length of a third side of the triangle. So the first question tells us, and I'm going to keep doing the first question in purple, xy is equal to 30, find mn. So xy, this whole side, is 30. We're looking for mn. Well, mn is parallel to xy, and mn is half of xy. We're also told that angle YNP is 84. So I go ahead and I fill that in. And then I'm asked to find the measure of angle Z, which is up here. So if I take a look, I have here that this angle, let's go ahead and fill in our parallel sides. I'll use a red pen for that. This side's parallel to this side. This side's parallel to that side. These guys are parallel. And these guys are parallel. Okay, that being said, if I turn my picture around, we can see, hopefully you can see, that using PN is parallel to ZX, I can see that this angle right here and this angle right here are a pair of corresponding angles. Do you see the upside down, backwards F happening here? And therefore, if those are corresponding angles using, again, these two parallel lines with this transversal, then angle Z must be 84 degrees. If the perimeter of triangle MNP, that's the triangle formed by the midsegments, is 36, then what's the perimeter of the big triangle? Well, I don't know. Again, we're ignoring the 30 from the previous example. I don't know the length of segment MN, but I do know if it happened to be X, I'm going to use a blue pen for this. If this happened to be X, this side would happen to be 2X. And if this happened to be Y, this side would be 2Y. And if this happened to be Z, this side would be, 2Z. So if that's the case, what I know is if I add together X plus Y plus Z and get 36, then the question's asking me what happens when I add together 2x plus 2y plus 2z. What do I get? So if you take a look here, all of these terms have a 2 in them, so I can factor out a 2, which leads to this. And at that point, I know x plus y plus z is really 36, referring back again to, if we look here, here's x plus y plus z, here's x plus y plus z equal to 36, and therefore I see that the perimeter of xyz will actually be double the perimeter of the triangle formed by the midsegments. Okay, we are going to stop right here. I would like for you to please complete the examples on the page 3 of the packet. Do not do the example on page 4, and we will do that example in class, okay? Thanks very much. Stay classy.